welcome to our second class on conjugate sorts. We want to continue with examples so that we can have a mastery of what we mean by conjugate sorts and how to solve them. Let's look at some other example. Simplify root 5 plus 3 over 4 minus root 10. Simplify root 5 plus 3 over 4 minus root 10. So what do? We rationalize or simplify with a conjugate sort of 4 plus root 10. That's root 5 plus 3 into 4 plus root 10. Then 4 minus root 10, open and close bracket, into 4 plus root 10. 4 plus root 10 is a conjugate of 4 minus root 10. It will give us difference of 2 squares. That will be that will be 4 square minus root 10 square. So let's multiply. Root 5 times 4, that's 4 root 5. Root 5 times root 10, that's plus root 50. Root 3 times 4, 12, plus 3 times root 10, that's 3 root 10, over 4 squared minus root 10 squared, difference of 2 squared. So let's simplify. What do we have? 4 root 5. Root 50 is the same thing as 25 times 5. Root 25 times 5, that's 5 root 2 plus 12 plus 3 root 10. So over 4 times 4, 16 minus 10. So what do we have? We have 4 root 5 plus 5 root 2 plus 12 plus 3 root 10 all over 6. This will be the answer we will be having. 4 root 5 plus 5 root 2 plus 12 plus 3 root 10 all over 6. 2 root 5 plus root 3 over 5 root 3 minus 3 root 5. So how do we do this? The conjugate of this will be 5 root 3 plus 3 root 5. So we multiply both numerator and denominator by that. 5 root 3 plus 3 root 5 over 5 root 3 minus 3 root 5, open and close bracket, open and close bracket, 5 root 3 plus 3 root 5. So now let's expand. 2 root 5 times 5 root 3. 2 root 5 times 5 root 3, that's 10 root 15, plus 2 root 5 times 3 root 5, that's 2 times 3, 6, 6 times 5, because root 5 times root 5 is 5. That will be 6 times 5, that's 30. Root 3 times 5 root 3, that's 5 times 3, 15. Plus root 3 times 3 root 5, that's 3 root 15, all over 5 root 3 squared minus 3 root 5 squared. So what do we have? We have 10 root 15 plus 30. 30 plus 15, that's 45. So plus 45 plus 3 root 15 all over 5 root 3 squared is 5 times 5 times 3, that's 75. Minus 3 root 5 squared, that's 3 times 3 times 5. 3 times 3 is 9. 9 times 3 times 3 is 9. 9 times 5 is 45. So our final answer will be this. 10 root 15 plus 3 root 15, that's 13 root 15 plus 45 all over 30. 75 minus 45 will be all over 30. 13 root 15 plus 45 all over 30. This will be our answer for this question. Thank you. Simplify root 7 plus 3 root 3 over 2 root 7 plus root 3. So the conjugate of this question will be 2 root 7 minus 3. So we multiply both sides, numerator and the denominator, by 2 root 7 minus 3 minus root 3. 2 root 7, 2 root 7 plus root 3. So let's expand. Let's open the bracket. Root 7 times 2 root 7, that's 2 times 7, that's 14. Root 7 times root 3, that's root 21. Plus root 3 times 2 root 7, that's plus 3 root 3 times 2 root 7, that's 6 root 21. Plus times minus is minus. 3 root 3 times root 3, that's 3 times 3, that's 9. All over 2 root 7 squared minus root 3 squared. So 14 minus 9. 14 minus 9 will give us 5. Root 20, 6 root 21 minus root 21. That will give us 5 root 21. All over 2 root 7 squared. That will give us 2 times 2, 4. 4 times 7. That's 4 times 7, that's 28 minus 3. So that will give us 5 minus 5 root 21 all over 25. This answer can be left this way, or we can come and say 5 into 5 minus 1 minus root 21 over 25. 5 here 1, 5 here 5. So our final answer will be 1 minus root 21 all over 5. That would be our, sorry, this should be plus, 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 because 6 minus 1 is 5. So our answer will be 1 plus root 21 over 5 as our final answer. 1 plus root 21 over 5. 5 root 7 minus 3 root 2 over 2 root 7 minus root 3. The conjugate of this question is 2 root 7 plus 3. So we multiply the numerator and the denominator by that factor. 2 root 7 plus 3 plus root 3. 2 root 7 minus root 3. Open and close bracket. 2 root 7 plus root 3. So let's expand this question. Root 7 times 2 root 7, that's 2 times 7, that's 14. Root 7 times root 3, that's plus root 21, minus 3 root 2 times 2 root 7. 3 times 2, 6. That will be 6 root 14. That will be 6 root 14. Then minus 3 root 2 times root 3. That will be minus 3 root 6 over 2 root 7 squared minus root 3 squared. So that will give us 14 plus root 21 minus 6 root 14 minus 3 root 6 over 2 times 2, 4. 4 times 7, 28 minus 3. That will give us 14 plus root 21 minus 6 root 14 minus 3 root 6 all over 25. This will be the answer in this way. There's no commonality here at all. Root 21 is root 3 times 7. Root 14 is root 2 times 7. So there's no way we can bring any like times together. Root 6 minus root 3 over 2 root 3 minus 1. The conjugate of this will be 2 root 3 plus 1. So we multiply the numerator and the denominator by 2 root 3 plus 1. 2 root 3 plus 1. 2 root 3 minus 1. Open bracket. So let's expand. 2 root 6 times 2 root 3. That's 2 times 2, 4. 4 times, that will be 4 root 18. 2 root 6 times 1. 2 root 6 plus 2 root 6. Then we say minus root 3 times 2 root 3. That will give us minus 6. Root 3 times root 3 is 3. 3 times 2 is 6. Then we have minus root 3 over 2 root 3 squared minus 1 squared. So root 18 is same thing as saying root 9 times 2. So the square root of 9 is 3. So it will be 4 times 3 root 2. 3 root 2 is expressed as root 18. 3 times 3, 9. 9 times 2 is 18. Plus 2 root 6 minus 6 minus root 3 all over 2 root 3 squared is 2 times 2, 4. 4 times 3, 12. 12 minus 1. So what we have will be 12 root 2 plus 2 root 6 minus 6 minus root 3 all over 11. That will be our final answer this way. We can bring the minus 6 here and bring the minus root 3 this other way. But this is also okay as our answer. Here's the last question on conjugate sorts. This is very unfamiliar, this particular question on conjugate sort, but let's try and see what we can do or make out of it. This question is particularly different from every other question we've been doing. Every other question did not require us to put a square here. Every other question does not require us to put a square here. We have been doing it without a square. But this particular question stipulates that there is a square. How do we solve a question like this? First and foremost, let's do as if there were no square. Express this as a conjugate of itself. What is below, the denominator is a conjugate of what is above. So let's just express as if there were no square. So multiply the numerator and the denominator by 3 root 3 minus root 2, root 3 minus root 2. So 3 times 3, 9. Root 3 times root 3, that's 3. Root 3 times minus root 2, that's minus root 6. Minus root 2 times root 3, that's minus root 6. Minus times minus is plus. Root 2 times root 2 is 2 over root 3 squared minus root 2 squared. That will give us 3 minus 6 root 6 minus root 6 minus root 6. That's minus 2 root 6 plus 2 over root 3 squared is 3 minus root 2 squared is 2. So our final answer will be 3 plus 2. That's 5 minus 2 root 6. This will be our answer. Then, since we have simplified this to be this, we'll just say square. What we'll now do now, this is our answer for this. We will now come and simplify what this is. This is our answer, then we put our square. So when we express this without the squared, we got this. Then we put our squared now. So this will give us 5 minus 2 root 6 into open bracket and close bracket, 5 minus 2 root 6. So 5 times 5 is 25. 5 times minus 2 root 6, that's 10 root 6, minus 10 root 6, minus 2 root 6 times 5, that's minus 10 root 6, minus 2 root 6 times minus 2 root 6, 2 times 2 is 4, 4 times 6 is 24, 2 times 2 is 4, 4 times 6 is 24. So what do we have here? 25 plus 24, that's 49, minus 10 root 6 minus 10 root 6, that's minus 20 root 6. This becomes our answer. With all of these questions, I want to believe that we have been able to have a mastery, understanding, full understanding of what we mean by sorts. This will be the end of our lessons of sort. We've done introduction to sort, addition of sort, subtraction of sort, multiplication of sort, division of sorts, and then we have also come to the last segment, binomial sort and conjugate sort. In our next class, we'll be going into logarithm, delving in details into how we treat logarithm question. Thank you. Please don't forget to share, to subscribe, to like, so that each time we come and do tutorials like this, you can be notified, and it can also help as many that may need things like this. Meet you in our logarithm class. Thank you.